we're going to move into the vertical dilation, and that just makes it stretch. That's why we call them dilation. We can also compress or shrink is sometimes the word choice that we use. But anyway, we're given f of x is written like this, and the first thing that they do, just a reminder that this is saying that you're doubling, so g of x is equal to doubling f of x, which in other words means that we are multiplying every piece in here by 2. So I'm going to rewrite g of x. I won't show you as much work for h of x. We're looking at 2x squared minus 8x minus 10. So then what does h of x look like? Well, it looks very similar, except we're dividing everything by 2, because it's half. And I hope you would realize that dividing by 2 is the same as multiplying by 1/2. So you're going to see me rewrite this function. So I'm not dividing the g of x by 2. I am dividing h of x by 2. So minus 2x, 4 divided by 2. And then I just like to leave it as 5 halves. I mean, if you really want to, you could rewrite it as like 0.5x squared minus 2x minus 2.5. I'm not going to judge you for the decimals. So on our graphing calculator, they're going to ask us to sketch and label the curve on a set of axes. So I'm going to use your graphing calculator and just type that in. We had x squared, I already forgot, minus 4x, minus 5. And then the next one, this is what I like about a graphing calculator so much too, is I can tell the difference by the color. Minus 8x, minus 10. And then this last one, I'm going to do the decimals. 0.5x squared minus 2x minus 2.5. So as I look at the graph of this, well, I can't quite see the red one because it was stretched out. But what I could do is I could actually change my window to go down to, I don't know, negative 16. Still not good enough. Negative 20. There we go. Now it looks like I can see it. Which I should have looked at my picture here and clarified that. So just as if you didn't have a graphing calculator with color, I'm going to label them all. And if you notice, they all share the same x-intercept, but they look like they were pulled apart from each other. And I'm going to go ahead and do letter C before I actually type this in, is we can find the minimum by hitting second trace and then the third option down, enter on that one. And what you have to do is move your cursor around, and if I want the minimum on F, that was my dark blue one, I have to hit enter to the left of my minimum, enter to the right, and then somewhere in between. And the calculator is not that smart. This was supposed to be x equals 2, y is negative 9. So 1, 2, negative 9. The value is the y value. And what you'll see is that they all are going to occur at x equals 2. So this is that point. Let me go back. They each had an intersection, an x-intercept at negative 1, 1, 2, 3, 4, 5. So at negative 1 and 1, 2, 3, 5. And our curve opened up something like that. And you should also notice for the graph of f that the y-intercept was negative 5. So that would be 0, negative 5 here. And let's just think about it, is if the minimum on f was negative 9, kind of want to use green again, I hope it makes sense that the minimum for g would be negative 18 because we were doubling every value. So I know I didn't label that point, but it was 2, -9, and this one's 2, -18. And you might even look at that and say, well, even the y-intercept was doubled. Looking at this value right here. But you might be confused why the x-intercept didn't change. And my best explanation for why the x-intercepts don't change is because, so that was G, is that these x-intercepts have a y value of 0. So it's 5, 0, and same thing over here was -1, 0. Well, what happens if you double 0? It doesn't change. What did I even write right there? There we go. Let me fix that. That was bugging me. 2, -9. There we go. And then it might even make sense then that the minimum value would be -4.5, happen at x equals 2. Its y-intercept was also -2.5. And it was a lot wider of a graph. And I'm just going to put it over here and call that h. So what points did not vary, and that the reason why they, the points that did not vary were the x-intercepts. And it's because it's when y equals 0. And whether you multiply by 2 or multiply by 1/2 or divide by 2, doubling 0 is going to still be 0. So the x-intercepts will always stay the same whether you multiply or divide. And then here's kind of a quick summary of what we have. Most books say stretch when you're multiplying by a k value that is bigger than 1. And then some books might call this a compression, which is what's happening here. I've also seen books use the word shrink. I don't know if they're in love with using S for these dilations. But it's compressing the graph so they come close together. Notice that these k values are between 0 and 1. And as a reminder before we move on is the negative values make it a reflection, which we already talked about in the previous lesson. So let's examine some more parts of this. So what we have is this point is on the graph of y equals f of x. So what point must be on the graph of this? Well, the thing is you're tripling the y value. So in other words, the x value does not change. So triple the y value and the x value is the same. So look at the one that has the x value is the same, -3, but then 12 times 3 gives me 36. So we're looking at option 2. So here's another picture, and all I'm doing is I'm doing a couple of transformations. So g of x is defined as doubling f of x. When you double, we call that a vertical stretch, because 2 is bigger than 1. That's why it's a stretch. And we usually write out by a factor of 2. And then the second thing, and again the order does matter, is this is a shift down 3 units. So as I look at g of x, and I've sometimes done this with students, is I've had them write out ordered pairs for f of x. So like this ordered pair is 1, 2, 3, 4, 5, 6. So we're looking at -6, -2. The x value, as far as we're concerned, is staying the same. So it's still going to be -6, but what you have to do, I'm going to switch colors, is you have to double that y value of -2 from right here. I'm following these rules, by the way, and subtract 3. So where's my new point going to fall? Still -6, but then -4 minus 3 makes it -7. 3, 4, 5, 6, 7. So same thing with the next point. That looks like it's -3, 1, 2, 3, up 2. So it's going to be transformed. The x-coordinate stays the same, but you have to double the x-coordinate. I meant to change colors again, sorry. Double the x-coordinate and then subtract 3. So doubling 2 is 4, minus 3 is 1. So that new point will be right here, and you can just connect those dots. Now you might be confused because I said the x-intercept stayed the same. Well, the x-intercept would have stayed the same except it was shifted down 3. So it might make sense that that ended up right there as well. So if we look at the next point, which looks like it's 2, 1, well, the 2 stays the same, but then you have to double the 1 and then subtract 3. So 2 minus 3 is -1. And I've run out of room. But it might make sense. So 1, 2, 3, 4, 5. If I double 5, I'm at 10. Minus 3 is at 7. 6, 7. And it might make sense, although I'm not entirely sure if it does, that if you double a number and then subtract 3, that's where your new x-intercept would be. So this would be your graph of g of x. And then our last exercise, we have a new function h of x. So we're starting over. It has a range from 2 to 10. So remember, range are the y values. So we are good to answer this question. And we have this new function that has a stretch of 3 halves and shifted up 8. So what you need to do is change each bound. Just kind of want to change colors. And sometimes what I'll actually tell students to do is just replace the 2 in for h of x. And so when you're looking at that, 3 times 2 is 6, divided by 2 is 3, plus 8 is 11. Hold on. I definitely did that right. I went back to the answer key. And so I'm going to just make option 1 go from 11. I need to change this in my notes. And then do the same thing with the 10. So it would be that 3 halves times 10 plus 8. So 30 divided by 2 is 15, plus 8 is 23. Yeah, so we're going to make this option 1. Now I got to fix that. If it's not fixed in your notes, that's because I got to it before I assigned it. And then the next one, we have a quadratic, has a y-intercept of 12, and then if we triple that function and subtract 5, we can find out where its new y-intercept is. And we're going to follow through that process. 3 times 12, and then minus 5. So 36 minus 5 gave me an answer of 31. Option 4. And hopefully now you are ready for your homework.